Okay, in this presentation we are going to look at inference procedures, and in particular what we're looking at is the difference in proportions. So what we're going to do is consider two populations, and here the two populations are two different patients, flu patients assigned to two different treatment groups, okay, who are given two different treatments. That's our two populations there, and we have a sample from both populations. 500 newly diagnosed flu patients were randomly assigned to one of the two treatment groups. Some were assigned to treatment group 1 and some were assigned to treatment group 2. So what we're asked to do is test the 2-day recovery rate. Test that the 2-day recovery rate is the same for both groups. Clearly state your null and alternative hypothesis and your conclusion. Use a significance level of 5%. So this is the key pieces of information there, and I shouldn't use that pen size. This is the key pieces of information there. Okay, so out of 280 assigned to the first treatment group, 168 had the flu after 2 days. Of the 220 assigned to the second treatment group, 176 had had the flu after 2 days. Just as a quick remark, it's not hugely important really, but it's actually we're asked for the 2-day recovery rate, and those are the people who don't recover. Okay. Now, actually, the difference in proportions works out the same. So in the long run, it doesn't work out to a big problem. But you might get docked marks for it unless you actually state exactly what you're doing. So we're going to use a 4-step hypothesis testing process, and I'll let you just sort of pause and have a quick read of that there. But that is the game plan of what we're going to do. So it sort of assumes that we have statistical tables, and also assumes that we might have some formula sheets available to us. Okay, now this step is very important, the hypothesis test, because we're actually asked for this in the question. So the null hypothesis proposes that there's no difference in the 2-day recovery rate between the two treatments. The alternative hypothesis proposes that there is a difference in the 2-day recovery rates between the two treatments. Okay, so that it doesn't really ask us is one better than the other. It just asks us are they the same. So here's our population proportions, and now this would sort of signify all flu patients who would take either treatment 1 or treatment 2. What are the recovery rates for both treatment groups for everyone in the world, every flu patient in the world who takes one of these treatments? So the null and alternative hypotheses are that they're equal to each other or that they're not equal to each other. Now I'm going to restate these in terms of the difference in proportions there, because that's just slightly easier to work with from the point of view of the question we're going to do. Pi 1 minus pi 2 equal to 0. Pi 1 minus pi 2 not equal to 0. Okay. So what we're going to do here is calculate the test statistic. Now, really, just be careful about what you're doing here. You can actually be okay. You're okay with doing this, but actually, if you're talking about who've not recovered within 2 days, so you can just use the values as given. Okay, it's 60% and 80% do not recover it within 2 days, but those who do recover within 2 days, if that's the 2-day recovery rate, is sort of what we're asked. So it's just the complements of those. It's 40% and 20%. Okay. So the point estimate is the same in both cases. It works out to be 20%. Now you can actually correctly. This is that's correct there. But if you were to sort of use the other one there, it would be minus 20%. But you could just flip it round. Go P2 minus P1. Okay, P hat 2 minus P hat 1. So it's not such a big deal. Anyway, our point estimate there is 20%. That's our difference in proportions. Now, so this is the standard error, and hopefully you might be seeing something like this in the back of your exam paper. This works on the basis of an overall proportion. Okay? And so again, it doesn't really matter a whole lot. I've actually done it in the context of the people who don't recover. Okay, but because the complement of that is the people who do recover, it works out both ways. So both of the correct numbers will turn up down here anyway. Okay, so it's 0.688, so the aggregate proportion was 68.8%. But if you're actually looking at it from the point of view of those who did recover, it would be 31.2. Okay? So just be careful about which way you've done it there. I just sort of followed the first way, but you could actually equally sort of say 31.2% there if you're working on the basis of those who did recover. As long as you're consistent. And again, overall, you won't lose that many marks really either way. So 68.8 times 31.2 times 1 over 280 plus 1 over 220. So I'm just going to break those up into two calculations there. 68.8 times 31.2 gives us 2,146.56. And 120, 1 over 280 plus 1 over 220. There we go, 0.00811. Working that out, we should get about 70%, 17.408%. Okay. And when we get the square root of that, 4.17. Okay. 23. And our test statistic is denoted TS. It's a normally distributed random variable with this specification here. You can just put in something like that just to sort of say what TS is. Critical value I'll explain shortly. But it's essentially our point estimate minus the expected parameter value under the null hypothesis. Under the null hypothesis, we expect a difference of 0. So that's where this 0 comes from. Okay. And we observe 20%. In both cases, recovery or non-recovery. And 20 minus 0 divided by 4.1723, that gives us 4.8. 4.79. We'll leave it as 4.79. That's our test statistic. Now, I won't spend too much time on this, but essentially the key things here are that we have a very large sample size, it's a two-tailed procedure, we're going to use a significance level of 5%. So in that case, our critical value is going to be 1.96. Okay? So this is a threshold that we must cross in terms of the strength of evidence. Okay? Now, if you're not familiar with where this 1.96 comes from in the context of a 5% significance level, you probably have to just backtrack a bit. You should be fairly familiar with this by now. Okay? The significance level of 5%. Okay? So our conclusions, yes, we reject the null hypothesis, or no, we fail to reject the null hypothesis. Essentially, we're making a determination about the strength of the evidence. The critical value is a sort of threshold we have to cross to consider our evidence strong enough. Okay, so is the absolute value? So that's it there. So essentially, it is. It's the strength of the evidence there. So I'll just continue on. Now, correctly, actually, there should be absolute value of the test statistic. Okay, is the absolute value of the test statistic greater than the critical value, where the critical value is the corresponding to the sample size? Okay, so in that case, we reject the null hypothesis. Otherwise, we'd fail to reject the null hypothesis. Here, it is obviously here we fail to reject the null hypothesis. Apologize for that. Here, the critical value is 1.96. The test statistic is 4.79. So we can definitely reject the null hypothesis. There is definitely a big difference in the effectiveness between the two types of medication, the two treatment types for flu. So in that case, one is definitely different from the other. Okay, and you could say it better. We didn't actually ask that question in the test, but that would beget another hypothesis test. Anyway, we leave that there.